In this set of notes, we're going to start to look at systems of nonlinear equations. When we're talking about nonlinear equations, all we're saying is that the two equations we're given will not be lines. One might be a line, but the other one will often be something else. It's important to remember your original library of functions along with all of the other things that you know how to graph. You should be able to graph these things very easily without creating long t-charts. Don't forget the original library of functions includes lines, absolute values, parabolas, square roots, cubics, and cube roots. We also studied graphing exponentials, graphing logarithmics, and of course graphing circles. When I look at my first one, I'm just looking at solving by graphing at this point so that we can understand our algebraic solutions. On my first graph, I've graphed my line. The pink line here is for my second equation of my line that was in slope-intercept form. This second equation might not be immediately obvious to you what it should be because we see the square root and we often think that it would be a square root function. What we need to notice is that underneath that root, we do have a squared term. If we squared both sides of this equation, we would actually have the equation for a circle. But since we only have the positive value, we only want the top half of the square root, or of the circle. It's important to notice that when we graph this, we can see that our line is actually passing through this semicircle in two places. So when we get to the algebraic solution, we expect to find two answers. Moving on to example 2, just thinking through our types of graphs. My pink equation is the equation for my circle with the center at 0, 0, and my radius is just a little bit more than 3. I need to remember that the right-hand side of this equation is not the radius itself, but is in fact the radius squared. So when I went to graph this, I simply did the square root of 10. Again, my blue line in this case was in its slope-intercept form. Down in example 3, I can see that I've graphed two circles. The first equation is my blue circle with a center at 0, 0 and a radius of the square root of 8 or 2 square root of 2. My pink circle, however, when I look at the equation, I notice that it's not yet in its standard form. So if I was going to graph that one, I would need to remember to complete the square before I try to graph it. So of course I would insert my blanks on each side, take my 4 divided by 2, square it, and I would get 4 to balance my equation. So writing it in its final form, I can see that the center for my pink circle should be 0, -2 with a radius of 2, and that's what I've graphed. Again, when I look at the graph, the system of equations, the solution, is where the two graphs intersect. So algebraically, I'm ultimately looking for these two ordered pairs. Moving on to the next page, we can look at more of our graphs. Again, I've graphed my line, which is my first equation here in blue, and then I've graphed the equation for my parabola. Remember, I have a variety of ways that I can choose to graph this. I can either try to factor it, I could find my vertex and then choose some points, or I could make a simple t-chart. I would, on this one, because it's in standard form, I would find my vertex using my -b over 2a. So I would have 6 over 2 or 3, and I would get the x-coordinate of my center, or of my vertex. Again, I can see that my line and my parabola are intersecting in two places, so when I solve it algebraically, I'm looking for those 2 points. On example 5, I have another circle, and this time another parabola. This parabola is going to take a little bit more work to rearrange it. If I want to rearrange this one, I would go ahead and I'd have my -2y, my -x squared plus 8, and then I would go ahead and I would divide by 2. Now I can see that this parabola has been shifted down 2, and it's been compressed vertically, stretched vertically, so it's going to be a little bit narrower. So I can easily find the x-intercepts and sketch my graph. This time I'm actually looking for 3 points of intersection when I do my algebra. On my last equation, I have a rational function. Although it doesn't immediately look like a rational function to us, we would also want to rearrange this one to allow us to see the standard form for our rational function. This is just going to be our parent graph, so it should be quick and easy to graph. And again, I have a line. Again, just to call your attention, we do need to make sure to remember that when we're solving algebraically, we are looking for both of those ordered pairs.